Good day, everyone. I am Mr. Gerald C. Apostol, and I am going to present to you the introduction to the statistical package for social sciences, or what we call the SPSS. So let us start. The goal of this presentation is to increase your knowledge and requisite skills on the use of SPSS, and for you to maximize this powerful software package independently on your own data and provide a solid foundation for advanced data analysis work. So what is SPSS? SPSS is short for Statistical Package for Social Sciences, and it is used by various kinds of researchers for complex statistical analysis. The SPSS software package was created for the management and statistical analysis of social science data. It was originally launched in 1968 by SPSS Incorporated and was later acquired by IBM in 2009. What is SPSS? So SPSS provides data analysis for descriptive statistics, numeral outcome predictions, and identifying groups. So SPSS is mainly used in the following areas like healthcare, marketing, and educational research. Market researchers, health researchers, survey companies, education researchers, government, marketing organization, data miners, and many others. It provides data analysis for the descriptive statistics, numeral outcome predictions, and identifying groups. This software also gives data transformation, graphing, and direct marketing features to manage data smoothly. We have here uses of SPSS. SPSS will be used for two distinct purposes. It is for data management and data analysis. The data management component involves defining variables, coding the values of variables to exploit the power of the software package, entering and editing data, creating new variables, and recoding variables and selecting cases. The objectives of the data analysis component are relatively straightforward. SPSS contains a broad range of statistical routines. The focus will be on standard objectives for summarizing a dataset in numerical or graphical form. Frequency counts, bar charts, and cross-tabulation will be used for categorical data. Standard numerical summaries, box plots, and histograms will be used for continuous data. So we have here for data management, the list sets out the major components of data management that we will cover. So number one, defining variables, coding variables, entering and editing data, creating new variables, recoding variables, and selecting cases. On the other hand, for data analysis, we have here the following: univariate statistics, bivariate statistics, and the multivariate statistics. So univariate statistics are calculated on the basis of a single variable. A set of summary measures are used to describe the data on a single variable. Bivariate statistics are calculated from data on two variables. Bivariate statistics are commonly used to measure the level of association or causation between two variables. For multivariate statistics are calculated on the basis of more than two variables. Again, the level of association or causation between the variables is the primary interest. The distinction between association and causation is important. Measures of association treat variables in analysis as equal. There may be a relationship between variables, but the direction of the relationship is not specified. Causation postulates one or more variables as independent variables and one variable as a dependent variable. Regardless of how sophisticated the data technique is, the data analysis will only be as good as the data that is based on. The data entry may not be terribly exciting, but it is of crucial importance to the quality of the analysis. So here is the question: why use SPSS? The reason why we are here, or why I am talking right now in front of you, is about research. So research needs a lot of time, effort, energy, resources, and brains. From identifying the problem, looking for relevant and supporting literatures, instrumentation, collection of data, data analysis, up to the conclusion, SPSS is created to reduce the complexity and save time on data processing and calculation of necessary statistics. So as you can see here, we have a lot of mathematical symbols that are present. Kung isa kayo sa mga individuals na nahihirapan sa math or ayaw talaga sa math, research will be as difficult or times 10 difficult kung you are going to execute these formulas. So these are just few formulas na you are going to use if there is no SPSS. So it will be considered as a revolutionary software mainly used by researchers, scientists that will help them or you to process critical data in simple steps. You are just going to put the data and then click, 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 and then you are going, the SPSS will give you the results. So working on data is a complex time consuming. Working on data is complex and time consuming. But this software, the SPSS, can handle and operate information with the help of some techniques. So SPSS will make the calculation easier. You're just going to put the data and then the SPSS will give you your desired number. So your only task is you to analyze or you're going to make an analysis based on that results. So hindi na kayo mag-execute ng mga ganitong mga formulas. So the SPSS will do the work and then it is going to give you the different values and then kayo na ang bahala mag-a-analyze kung ano yung dapat na maging desisyon ninyo. For all SPSS version, the first screen that appears offers a range of options that effectively fall into two broad categories. So the first category is to obtain help through the online tutorials. As you can see, the first option there is to run tutorial. So SPSS comes with an online tutorial to help new users familiarize with the whole interface. So the second category is loading data into SPSS. This can be done by typing data, extracting data from database with an existing or new query, or opening an existing data file. So the first screen is largely cosmetic, or most practice users quickly skip it, knowing how they intend to enter data into SPSS. So clicking the checkbox on the bottom left hand corner prevents the screen being shown in the figure. So for this time, let us just ignore this first screen. There will be two views. We have the variable view and we have the data view. So SPSS is built around a number of windows: the data editor, which comprise the data view and the variable view. So and the output and the syntax windows, which are the most important. So by default, SPSS opens the data view in the data editor. Starting from the top of the data editor consists of the little bar, the minimize, the maximize or restore, and the close buttons. So the menu bar, a toolbar, a cell information box, a cell editor, a matrix of cells, an active cell which is highlighted in black, horizontal and vertical scroll bars. At the very bottom, 5 status boxes appear. Only 3 are visible in the above slide, but 5 appear when the software is displayed full screen. When fully displayed, the status boxes give the following information. Number 1, the current status of the processor. For example, running or ready. Number 2, a case counter, which counts the processing of cases when an analysis is undertaken. And we have a filter status to signify that a subset of the data has been selected for analysis. And we have the weight status, indicating the weights that have been applied to data. And then we have a split file status box, indicating whether the data has been grouped according to a categorical variable. Okay, we have variable view. So variable view is used to define variables. Each row in variable view defines a single variable and correspond to the column in data view. The first row in variable corresponds with the first column on the data view. The second row to the second column, and so on and so forth. So the columns in variable view are the variable's attributes. Let us start with name. This is a column field which accepts the unique ID. This helps in sorting data. For example, the different demographic parameters such as name, gender, age, educational qualification are parameters for sorting data. The only restriction is special characters, which are not allowed in the name column. So next we have label. For the label, the name itself suggests it gives the label. so which also gives the ability to add special characters. Type. This is very useful when different kinds of data are being inserted. And we have width. We can measure the length of the characters using the width. And for the decimal, while entering the percentage value, this type helps us to decide how much one needs to define the digits required after the decimal. And we have the value. This helps the user to enter the value. And for the missing, this helps the user to skip unnecessary data which is not required during the analysis. Okay, for align, in short for alignment, it suggests align, short for alignment, helps to align left or right. And we have the measure. This helps to measure the data being entered in the tool like ordinal, cardinal, or nominal. For the data view, rows represent cases or observation, the objects on which data have been collected. For example, rows represent the contents of a single treatment data collection form, the information on an individual. Columns represent the variables or characteristics of the object of interest. For example, the column contains the answers of questions of the treatment data collected, like age, gender, primary drug, or etc. So the distinction between case or observation and a variable is important. Okay, let us go back with how to define variables. So let us go with the name. So each variable must have a unique name but not more than 8 characters, and it starts with a letter. Also try to give meaningful variable names, such as like describing meaningful variable names. Describing the character, for example, age, same as true with linking to the questionnaire. For example, A1, question 3 or Q3, and keep names consistent across files. So the questionnaires or data collection forms used by the participants are relatively small. Meaningful variable names are therefore possible. For larger questionnaires, setting up meaningful names for each variable is time-consuming. An alternative naming strategy is to use question numbers from the questionnaire as variable's name. So it is advisable to keep names consistent across files. For example, calling the variable gender in one file and calling it sex on the other file can cause confusion. Variable type. So variable type refers to either the way the variable is stored internally by the software package or specifies the format of numeric variables when they are displayed. Numeric, string, date refer to the internal storage. Numeric refers to numbers, string all alphanumeric characters or words. Date is stored as a number of seconds from the reference time and date. We also have comma, dot, and scientific notation, dollar, and custom currency. This refers to the output formats for numerical variables. For example, the display $30, the variable would have a type of dollar. So we also have here the numeric. Numeric variables are used for true numeric measurements such as weight and height, and where numbers are used to codes for categories such as 1 for male, 2 for female. So we have here defining numeric variables involves specifying variables. We also have alphanumeric. So string variables contains words or characters. Strings can include numbers, but taken there as characters, mathematical operations cannot be applied to them. So maximum size of a string variable is 255 characters. And we have the date. The input format for the date variables must be defined such as date, month, and year, or month, date, year, or month, date, year with two digits. So the last 2 digits of the year. Computers stores dates as a numbers from a base date in SPSS dates. So dates are stored in a number of seconds from October. Okay, I opened my SPSS application on my device, and the version I have here is the 15.0, and the product is licensed under mine. So this is the evaluation version of SPSS 15.0. Okay, so we have here, so as I have discussed a while ago, so we have two views. So we have the variable view and we have the data view. So our first step is to set up our variables. We have here 5 variables. So we have ID, gender, group. So when we say group, so if we are conducting an experimental research, so group means it's either uh, group means it's either the student belongs to the control group or the control class, or in the experimental group or in the experimental class. So we set group values as 1 for control and 2 for experimental group. And same as true with the gender. We set up the values for 1 for male and 2 for female. So that's all right kahit magkabaliktad yan. Same as true with the control and experimental. And we set them as nominal. So nominal, nominal. And we have pretest as a scale and numeric and so on. So let us go with our data view. So we have here the variables. We have the ID, we have the gender, we have the group, we have the pretest, and we have the post-test. So as you can see here, dito sa taas, so meron tayong file dyan. So you can actually open new data or create new data, syntax, output, draft, or script. You can actually open data that is already existing. You can open database, and pwede nyo i-save itong inyong ginagawa. Let us test if there is a significant difference between the pre-test and post-test of our control and experimental group. So before that, let's take a look kung ano ba yung mga descriptive statistics and inferential statistics na kayang gawin ni SPSS. So we have here the descriptive statistics. So for descriptive statistics, so we have here, let's put the gender, the group, the pre-test, and post-test. So kunin na natin lahat ng descriptive statistics na mga yan. But before that, we need to click the options. So here are the descriptives na pwede natin ipakalculate kay SPSS. We can have the average or mean or the sum, the standard deviation, the minimum and maximum. So we can also have the variance, the range, or the difference between the highest and the lowest score or entry or data. And then we have the standard error mean. We also have the kurtosis and skewness. So let's click continue. And then okay. So as you can see, we have here the table of the descriptives. So we have gender, group, pretest, and for our pretest, so as you can see, we have pretest and we have the mean. So we have here mean. Ang mean ng ating pretest is 4.3667, and we also have the post-test. So we have 22.366. So what else? So we also have frequencies. So let's check our gender and groups. So let's check for statistics. We can also calculate for the central tendency, the minimum, maximum, or the descriptives also here. So we can also have bar charts. For gender, there are 30. For group, there are 30. And for gender, as you can see, we have male, we have 7 males, and we have 19 females. Okay, and then so as you can see, there are 3 and 4. So it means there are invalid entries kasi in gender we also have male and female. So since nakita natin sa frequency table that there is 3 and 4, we can go back to our data view and take a look with 3 and 4. Palitan natin based doon sa questionnaire. So yun, so nakikita na paano natin i-treat to. So double check, tignan nyo yung questionnaire ng 10, 11, 12, and 13 to verify kung ano ba yung mga gender ng mga ito. Yung mga estudyante ito. Okay, since naayos na natin, let's rerun again. Okay. So as you can see, here is the new frequency table. So we have male and female. So we have 9 male, we have 21 female. So, and we have here the cumulative percent, valid percent, and we have the total. Same as with our group. So for our control group, there are 15 students. And for our experimental group, we have 15 also. So as you can see, we have here pie chart. So our SPSS can also generate different graphs. So it is located here. So graph, so chart builder. So we have interactive graphs. We have bar, dot, line, ribbon, area, pie, box plot, error bar, histogram, and so on. So we have here gender and we have male and female. So for groups, we have control and experimental groups, 50% and 50%. So next, what else? Ano pa ba ang pwede natin gawin dito? So we also have the means. So we can also compute for the mean. So our post-test and our pre-test. And for our group, we can put that for our independent list. And same as with our gender. So enter. these are the tables that our SPSS generated. So we have here the post-test, pre-test by group. We have them. So as you can see, we have here post-test and pre-test by group. So as you can see, we have here the control group and experimental group. And for our columns, we have here post-test and pre-test. So as you can see, for control group's post-test, it is equivalent to 18.6667 as the mean of their scores. And for the pre-test, they have 4.9333. And for our experimental group, we have 26.06 and we have 3.8 for their pre-test. So we have here 30. So for the whole class, the post-test average is 2.37 and for the pre-test average is 3.37. Using gender as our grouping variable, so we have gender, male and female. So for the test average for males is equivalent to 22 and for the pre-test it is 3.56. And for females average on post-test is equivalent to 22.52 and pre-test is equivalent to 4.71. So let us now go back to our data view. Okay, here is our problem. So based on our hypothetical data, we want to answer this question. So is there a significant difference in the post-test scores of the control and experimental group post-test? So let us include post-test and here is our problem. Is there a significant difference in post-test and pre-test scores of the control and experimental group? So let us go back to our SPSS. We have here the result of our independent sample t-test on pre-test of the control group and experimental group. So we're going to see if there is a significant difference between the pre-test of control group and experimental group. So we have here the p-value, which is equivalent to 0.409, which is actually higher than the 5% or the 0.05. It means that we are going to accept our null hypothesis. So our null hypothesis is actually there is no significant difference. So we can actually conclude that our control group and experimental group has no significant difference in terms of their pretest. And statistically speaking, control group and experimental group are almost equal. So just go to the compare means, independent sample t-test, okay, put post test, and we have the grouping variable 1 and 2, and then options, check if it is 95% and click OK. So we have here the p-value for our post-test of the control group and experimental group is equal to 0.003, which is less than our 5%, which is 0.05. It means we are going to reject our null hypothesis. So it means that the post-test of our control group and the post-test of our experimental group is significantly different. So there is a significant difference between the post-test of the control group and the post-test of our experimental group. Gamit ang SPSS, hindi na tayo gagamit ng napakadaming formula. So SPSS will give us the tables na nandoon na yung mga parameters and statistic. What we are going to do is just to analyze, or we're just going to interpret tables, the statistic, the parameters na binigay ni SPSS. So it will save time. Okay. I presented to you the introduction of SPSS, and we know that it is just a small part of what is SPSS. As a future educator and a researcher, always seek for a new knowledge and make the best out of it. So I have here an electronic book where you can find the guides on how to interpret the data or how to use the SPSS effectively and how to interpret the tables generated by SPSS. So I will send this to Ma'am Bell. So if you want a copy, just message Ma'am Bell, or if you have clarifications, you can send me an email. Research means that you don't know, but you are willing to find out. So that's all for this presentation. Thank you.